SoundBounce is a groundbreaking tunable acoustic material. SoundBounce uses smart acoustic materials to respond to the sound environment, both in terms of amplitude and frequency. We developed SoundBounce as a response to a problem our previous customers had. My co-founder Rona and I have worked with thousands and thousands of people who have tinnitus, a chronic ringing in the ears. The vast majority of them got this by working in noisy environments. The hearing protection there provided was either inadequate or in many cases not provided at all. We wanted to bring the power of noise-cancelling technology, which is typically electronic, to a broad market and create a durable product. And we looked to our knowledge of physics and how different smart materials respond to energy to find a material that would work for this application. We then created a patented cellular structure to house this smart material to make it sufficiently sensitive to sound energy. Not only that, but we can change the formulations of this material to tune it to absorb specific frequencies optimally. This is particularly useful when it comes to low frequency sound, which is a huge problem across a broad range of industries, and the aerospace industry is no exception. So here we have a graph at some very, very low frequencies. As you can see, the SoundBounce samples at the top two lines are vastly outperforming the foam in the red. In fact, if you were to get the same level of sound blocking of the foam as the SoundBounce, you would need the foam to be 30 times thicker. That's a huge space saving. And these are just prototypes. This is not as thin as we can go. This is not as light as we can go. Foam and other traditional acoustic materials are very limited. SoundBounce uses entirely different physics to look at the problem of noise. And in that way, we can vastly outperform them in many, many sectors. Myself and Rona have been working together for over 10 years. We're both physicists by training, and we bring this scientific expertise to creating new products with big global challenges. Our previous product that I've mentioned was Sound Relief, an online tinnitus sound therapy. This was a therapy that we brought through CE marking, venture funding, regulation, clinical trials, and we are now using that business acumen that we've developed alongside our deep scientific expertise to bring SoundBounce to a global market. And we spent a lot of time validating SoundBounce both scientifically and commercially in the $3.4 billion acoustic materials market. We've done third-party testing with both customers and universities. We're working on testing and product development projects with companies in the aerospace, hearing protection, automotive, and construction materials markets. SoundBounce is a groundbreaking and novel acoustic material, and we think it can solve the challenge of noise in the aerospace industry.
Yes, maybe one question. As Safran, we've been definitely interested by your technology when we saw it on the challenge. You might know that we have Safran Nacelle and Safran Aircraft Engine who are making the engine and the nacelle, the body. It seemed that functions for those nacelles are essential. Putting new functions to nacelle and acoustic functions could be very interesting. It seems that the required frequency is below 20 Hertz, what you were talking about. So is there any limitation in your technology to go below? You showed curves starting to 20 Hertz. Is it possible to go below?
There is no reason based on the physical principles that we're working on that we couldn't go lower. We haven't had access to a testing rig that goes lower than 20 hertz. So that was actually a special setup of testing that we managed to get even that low. Many industries just don't even test that low. So I think it's perfectly possible, but we'd love to test it out if you've got the rig.
So we saw you have your first industrial contract getting signed or underway. How far are you from having real material out in the field changing life of users.
Right. So it's like, as I've mentioned, we're dealing with a lot of different industries, and they're all at slightly different stages. So the hearing protection industry is one that we approached more early in our development. So we've got 2 projects in the hearing protection industry that are kind of coming towards the sort of mid to end of their development cycles. So those should be products potentially on the market 2017. And then we've got about 3 to 5 fairly significant product development projects in kind of architectural and automotive that we're looking at the moment. I'd say we'd be doing well if we can get some good functional kind of, well, regulation-ready products in mid to late 2017. With the view to having those on the market, but we have kind of new products and new projects and new industries coming on stream every quarter or so at the moment.
Yeah, since we are in an aerospace track and you don't give too many details about the materials itself, is this can you adapt your technology to different type of materials, or which would probably extend the specifications to fit the aerospace, or?
Yeah, so sorry, I didn't go into vast technical detail because of the amount of time. Basically, the materials we use are a class of materials, and they are non-linear materials that respond to energy in, well, kind of a different way to typical materials. But because it's a class of materials, we can select different materials and different combinations of materials, and then different housing materials, so that we can adapt to, say, different temperature limitations, flammability, well, really any kind of different environmental concerns, we can get around most of them, because it's a real platform technology in that sense. It's adaptable, and that's why we've had such traction across such a broad range of industries. Thank you so much.